Yes, hello, good morning, grade 11s. This is Smart Fismas tutor here in Polokwane. Yes, join me as we go through this June paper for 2025, Limpopo, grade 11, physics. Okay, here we go. Yes, let us continue. Okay, now as you can see, this is from Limpopo, grade 11, physics paper on June 2025. Yes, question 1.1. It says that a bird catcher observes a bird flying from A to B, B to C, and then from C to B. Let's say the bird begins from A to B, like this, okay? Like this is from A to B. So this is A up to B, and then they said from B to C. Now from B to C, from B to C, this is from there, that is B, and then to C, B to C, and then they said that after saying B to C, what happens next? Let's find out here. They say, and then from C to B, now back to B, back to B. So from, now they're saying from what? From C to B, which means that's our C there. From C to B, okay. From C to B, and then they say that which one of the following correctly describes the displacement of the bird? Now displacement is defined as the shortest distance between the starting point and the end point. Okay, so if you check from where the bird started from, it began from point A. Where is it now? At point B. So our displacement is going to be from A to B. So the answer is A. I repeat, from A to B, that's going to be our the shortest distance from the starting point to the end point. I repeat, the bird was getting from A to B, that's from A to B here in the blue arrow, then from B to C in the green arrow, then from C to B in the red arrow. Then they say the displacement of the bird is what we're looking for. So displacement is the shortest distance between the starting point and the ending point. That means final position minus what? Initial position. Okay, all right. Next question here, 1.2. 1.2. They say that a roller coaster moves from rest at the bottom of the rail and accelerates at a constant rate upwards. By the time it reaches the highest point of the rail, which one of the following will be correct? So we have a roller coaster. How does it move? From the it accelerates, okay? It accelerates at a constant rate upwards, meaning the same acceleration, okay? By the time it reaches the highest point of the rail, what's going to be correct? Now they say both the mass and the net force will have increased. Now the mass is constant, does not change, so this is not correct. Then both the velocity and the net force shall be increased. Let's find out now. Because it's accelerating, acceleration, actually net force, F net, our F net equals to mass times acceleration given by mass into V final minus V initial divided by change in time. So because of it is accelerating, you're gonna have the increase in the net force because it's accelerating. This value here is going to get bigger. So a bigger value times the mass is going to give us what? The increase from 0, because it was from rest. Rest, the F net was 0. So from 0 to a certain value after multiplying this mass times change versus change in time. So this is correct here because we have the velocity has increased from 0 to something here to the final. What about part C? Velocity and the net force will have remained constant. This is not correct because we saw that the velocity increased from 0 to v final. They said the velocity shall have increased while the net force shall have remained constant. Now again, this is not correct because the net force is not remaining constant. It changes from 0 to mass times acceleration. Okay, so yeah, our final answer is going to be B. Let's continue here. Next question, 1.3. The sketches 1, 2, and 3 not drawn to scale are different ways in which these point charges are arranged. The charges are identical in magnitude and the distance between the charges is the same. Now, the moment they say identical, what should come in your mind? They have the same charge. We can make it to be 2. You can make it to be 2 everywhere because they're saying it's the same charge everywhere. So it's going to be positive 2 here and negative 2 here, then negative 2 here. Then they say we have got option 1, this arrangement 1, 2, and 3. Then they say, in which of these arrangements will the magnitude of the net electrostatic force expressed by the positive charge be the largest and then the smallest respectively? So where are we going to have a largest T and the smallest T electrostatic force exerted on the positive point charge? So now the positive in this case is this one here. Let's find out what's going to be the net force on this positive charge here. Now if now the net force on the positive charge, now our D, let us give it a constant. Let us say it is 1 meter. Also here 1 meter. Okay, so now the net force here on the positive charge, I'm going to call it F net on the positive charge. It's going to be given by, let's find out here, by the force between this positive charge and the negative charge here, this one here. Okay, that's between let me call it F1 plus F2. Now the force 2 is between the positive charge and this other negative charge here. Okay, so now the force between the two charges is given by a constant K, okay, multiplied by the charge. Now our charge here is positive 2, that is positive 2, multiplied by this positive charge by the negative charge, which is another 2 here, divided by distance, which is 1 squared. Okay. Then plus between now our F2 is between the positive charge and this negative charge, the next one here. So also going to be by K multiplied by 2, okay, n times 2, because it is 2 here, as you can see. Difference is the distance. Now from this positive charge to this other negative, it's going to be 1 plus, it's going to be now 2 squared, which gives us it's going to be positive what? Positive 4K. This is 4K, then plus K here. Now because all this negative charge and this negative charge, they are both to the right of the positive charge, they're going to giving us the same direction, which is going to be they are going to be attracting the positive in this direction. Okay, so it means they're all going to have the same sign, which is going to be attraction, and it's going to be 5K. Now our K, we know it's a constant, which is what? 9 exponent 9. Okay, that's our answer here for this case. Okay, let us look at this option 2. Now option 2, this is my positive charge. I want the F net here. So the F net here will be by the force between this negative charge and the positive charge. That's going to be our K. That's going to be, again, when we say positive, it's going to be 2 multiplied by this 2 here. Okay, distance here is 1. Okay, and then plus again here this positive charge again, that's our 2 here, multiplied by 2 again, divided by distance, also 1 here. Now this one here, it is squared in both cases. It is the same because the positive charge is in the middle. Okay, so you're gonna have you're going to have 4K here and then also plus 4K here. But then here, listen carefully, Now, the positive charge is in the middle, unlike in the first case, whereby the two negative charges were pulling it to the same direction. Now, this one is pulling it in this direction here with the F4K, a force of 4K. What about here? This other one is pulling it this direction with a force of 4K. Now, if I choose right as positive, it's going to be negative here. In other words, here, my net is going to be 0 because negative 4 plus 4 gives me 0 newtons. Okay, so if I come here now, then side option here. Now, now in this particular case, we're looking for the force by the positive charge in all the diagrams. So in this particular case, if I consider this one from this point, okay. Now you see, because positive is attracted by the negative, it means this one can become like this here. This is the force between the positive charge and this negative charge here, which is in green. Then this other one, between the one which is up here, this negative also, because it is going to be attracting it upwards, it's going to be this arrow here now, which you see in a red color now, this one. So this arrow is going to come like this now, okay, because it shows that the positive charge is being pulled upwards, as you can see it here. Are we together? Now, because this is 90 degrees here, to get my resultant, what I do here, I use head to tail method, okay. Then my resultant now is going to be given by this other arrow now, which is going to be now in blue, okay. So to get my arrow in blue, I come here from the starting point, that's from the tail to the head of the second vector here. So in other words, I'm going to use Pythagoras because this 90 degrees here. So my F resultant on the positive charge will be given by this Fx and Fy, okay. So because it is a right angle triangle, my net force or resultant squared given by Fx altogether squared plus Fy squared, okay. Let's find out here now. Now our Fx here is going to be again given by K multiplied by because the charges are the same, it's going to be 2 times 2, okay, divided by 1. Distance is 1 by 1 squared. Don't forget to square our thing here, okay. So then plus the same one here, also going to be K multiplied by 2 again times 2 divided by what? By 1 squared, okay. Don't forget to square this. So now if I get my calculator here, and I don't forget our K, it is 9 exponent 9, okay. So let's check with our calculator here. With our calculator here, as you can see here, if I put my values, don't forget we know the K, but because with the square I'm going to find is actually square root. So square root of the first one, which is going to be 9 exponent 9 times 4, out together times 4, now bracket what? Squared, and then plus this other one, that is also 9, that's my K, 9 exponent 9, also times 4, bracket what? Squared, okay. So what does it give us here? It gives us 5,09 exponent 10, 5,09 exponent 10 newtons. Now compare these answers here. We're looking for the highest and the smallest. So in this case, I have got these answers here. This is 0. This is the smallest. Now this answer, this one here, and this one, which one is the highest? So we can say that this is 5,09 exponent 9. This is 5 exponent times 9 exponent 9. Okay, let's find out here. What is 5 times 9 exponent 9? That was our 5k. Let's check it here again. Now our 5k is 5 times 9 exponent 9, which gives us what? which gives us 4,5. Okay, this is 4,5 exponent 10. Okay, this is 4,5 exponent 10. Now, which one is the highest? This one is higher. So, it's going to be this one and this one, which means it's going to be the greatest is going to be for 3. So, you can choose from this one or this one. And then the smallest is going to be 0, which is what? Which is number 2, which is 2 here. So, meaning that our answer is going to be D, because we have got the 2 here, which gave us 0. So, the answer is D in this case. Let us proceed here. Next, 1.4. Magnetic flux linkage through a coil depends on. Now, magnetic flux linkage through the coil, we know is given by our phi, okay, equals to BA, then equals of what? Equals of theta. Okay, let's check here. This B is for the magnetic field, then the area here, then the direction here. So they say depends on the thickness of the wire in the coil. Now, that's not correct here. That's not thickness, there's no thickness here. Then the angle between the coil and magnetic field. Now that's what we see as cos of theta here. Okay. And then direction of the magnetic field, we don't have it here. Then material the coil is made of, we don't have it here. So the answer is going to be B here. Between the angle between the coil and magnetic field, which is cos of theta. So that the answer is B. Let's continue here. 1.5. They say 3 identical resistors X, Y, and Z are connected as shown in the table in the circuit below. They're saying identical. So guys, the moment you see the word identical, choose a number. You can choose 1 or 2. So I will choose a 2 here and a 2 here. Okay. And then this cell, I'm going to give it a value. Because there are 2 cells, I'm going to say 1,5 times 2. Let me give it 3 volts. Okay. So they say that if the power in X is P, and then the power in Y is going to be what? So I'm looking for the power in X, and then the power in Y. I'm going to compare the two. Okay, so here, how do you find the power? Now the power can be given by P equals to V squared divided by what? By resistance. Or P, yeah, that one is fine. I think first here. The question said that 3 identical resistors X, Y, and Z are connected as shown in the circuit below. If the power in X is P, then the power in Y is going to be what? Now, if these are 2 here, what's my total resistance here? Now, if there are only 2, the resistance in parallel, which I'm going to call RP, is going by the product over sum. That means 2 times 2 divided by 2 plus 2. Okay, it gives us 4 over 4, and such that we get 1. So here, our total resistance is what? Our R combined is 1. Our RP is 1. Okay. Now, this voltage, which is 3 volts here, it is going to be distributed depending on the resistance. This is 2 ohms. This is 1 ohm. So because of the 3 volts here, I'm going to be having it's going to be distributed like this here. I'm going to be having 2V here. Okay, 2V here. Then here, because of the 1 ohm, it's going to be only 1V. Don't forget the total was 3V. So 1V. Now, because these two are in parallel, the V for Y, the same as the V parallel, which in this case is going to be 1. So if I come here to get my power, they said the power, if the power in X is P, so it is find the power here. So the power in X equals to the V squared divided by resistance. So our V here in X we go to what? Which is 2V. So 2V squared divided by 2, which gives us what? Which gives us a 2 here, 2 watts. What about the power in Y? Now the power in Y equals to V squared Y divided by the what? By resistance of Y. So V squared, the V here we saw it is 1 squared divided by 2, which gives us what? Which gives us 1 over 2. So this is what's here. So mean that the power in y, if I compare the power in x is we go to what? Power in x, we go to what? Okay. Looking for the power in y, which is it is a half, ne? Half what's here. So and if you check here, they say that if the power in x is p, but the power in y is going to be how many p's? Now if you divide 2 by a half, you're going to get how many? You're going to get 4. So it means in this particular case, the power in y is going to be a quarter. It's going to be a quarter. It's going to be a quarter of the power in what? In x. So the answer is going to be this one here, which is C. Let us continue then. Next here. Question 2. The diagram below shows 3 forces of 10 newtons north, 12 newtons west, and 16 east on an object on the same plane. The diagram is not drawn to scale. So they say define the term resultant force. Now, resultant force is a single force which has the same effect as many forces acting together on the same system. They say calculate the magnitude of the resultant force acting on the object. Now, as you can see, we have got those which are horizontal and then vertical. So our F resultant, okay, our F resultant in this case is given by all the forces which are horizontal. Okay, I'm going to call them fx squared plus all the forces which are vertical, fy squared here. So now 16 positive, then minus 12 here. What do we get, guys? We're gonna get 4 squared, and then plus. What about here? Now vertical only have 10, so plus 10 squared here, plus 10 squared here. This is our f resultant squared. Don't forget here. So it's gonna be 16 here, then plus 100, which gives us 116 newtons. But because of the square, we are gonna do what? We're going to square root here. So our F resultant is equal to 116. Let's check it here. Root of 116, it gives us 2 root 29, which is same as saying what? 10,77. Okay, so this is 10,77 newton. That's our resultant force. Because they said the magnitude, they don't want direction for this case, so it is 10,77 newtons. Then they say here direction of resultant. Now our direction here, because here we have because this is positive x and positive y, so that in this particular case our diagram will look like this in this case. Okay, now down which is horizontal we see it is 4, right? It is 4. Then vertical is 10, so a 10 here like this. Okay, this is 10 here. Now they are both positive, and hence positive x and positive y. So to get our resultant here, which you guys see in red, this one here, resultant, I'm gonna use now. I'm looking for direction here, so looking for this theta. Now down which you see in red is my resultant force there. So I want this theta here. I want this theta here. So how do I get my theta now? If this is my direction theta, now my Fy, it was 10. You see it is 10 here. So this is 10. What about here? Here we got 4. Okay. So now I'm going to use tan theta. So tan theta equals to opposite, which is 10 divided by 4. So theta is going to be the tan inverse of what? 10 divided by 4. Okay. Let's check calculator here. Tan inverse of 10 divided by 4, shift 10 of 10 divided by 4. So 10 divided by 4 gives us what? It gives us 68, 20. 68, 20. So it is 68, 20. Okay, degrees. That's our direction then. Okay. Then they say here we should also find out. They say that a fourth force is added in the system such that the resultant force is 0. What's this force called? Now, if our resultant is like this as we see it here, to get another force added to it and making it is 0, so we call it equivalent. We call it what? We call it the equivalent force. We call it the equivalent. Now they say that determine the magnitude and direction of the force. Now, because this was our net force, as you can see pointing there, okay, which was our resultant. Now, to get something which is now the 0, to give us 0 now, the one which we call the equivalent must be in the opposite what direction? To be like this now. Okay, like this now. Green color here. Now, my equivalent must be of the same magnitude, like the one which you see in red. Okay, so this is my equivalent force here. I'm gonna call it F equivalent. Okay, it must be opposite to F resultant and must be of the same magnitude. Okay, so they say here that determine the magnitude and direction of the force. So now the F equivalent, I'm gonna call it F EQ, is gonna have the same, which is gonna be 10,77 newtons, but in what? In opposite direction. In opposite direction, because they said they want direction and magnitude. The magnitude is the same, but must be opposite direction. Let's continue here. Hope we are together. And then next question here. They say that block A of mass 4 kg is moving with a constant velocity on a rough horizontal table. This block A here, and is connected to another block B of mass 8 kg by a light inextensible string which passes through a light frictionless pulley. Okay, then a force of magnitude 896 newtons is applied vertically upwards on block B as shown in the diagram below. So this is block B, the force is 996 newtons and the mass is 8. This block A, the mass is 4 kg and the table is rough, so there's friction here. And this is what must we do? I said that state Newton's first law of motion in waves. How do you state it? A body will continue to remain at rest. Actually, the body will continue to be in its state of motion. That means it can be at rest. All will continue moving with the same velocity unless an external force applied on it. Okay. They said draw a free body diagram for block B. Now block B, as you can see, it is in the air. Okay. So there is applied force here, then tension, and then the weight. Okay. So if there's a free body diagram here, if the body is on the surface, you're gonna have normal force, but in this particular case, because we have the applied force and the weight and the tension, so our block would be something like this. We're going to have one force is pulling upwards. Okay, it's pulling upwards, one force, and then the other is pulling downwards. So don't pulling downwards now. I'm gonna call it so if this is my free body, the free body we're talking about here. Okay, so I have the upward force. Now if you know the value, you put it in, this 96 newtons. Then down we have the weight. We have the weight together with the tension. So we have the weight here, and then the tension in the string. Tension pulling like this downwards. Now this is our tension here. This is our tension here. Now this tension which you see in the green here is what is here. This is our tension here. So we have got three forces. We have the tension force in the string all together. Then we also have what? We also have the weight. So this is the tension T. This is applied force 96 newtons. It's the weight W. That's our free diagram here for 3.2. And then next, what must we do now? Let's check it out. They said that calculate the magnitude of the tension force acting on block B. Now, because this string is inextensible, means that the tension on block A is the same tension on this side of block B, but in the opposite what direction? Okay. So I'm looking for the tension, okay, and I know the applied force here is 96, and I know the weight. Okay, so because the body is in motion, I can find the tension using 22nd law of motion. Okay, so I'm gonna say that if I consider block B, this is now 3.3. Okay, if I consider block B, F net equals to MA. F net equals to what? Equals to MA. And let's check the question one more time here. They said that block A of mass 4 kg is moving with a constant velocity. Did you see that word? Constant velocity. Constant velocity, meaning z acceleration, okay? Means z acceleration. And on a rough horizontal table, and is wanted to another block B of mass 8 kg by light inextensible string which passes through the light frictionless pulley. Then a force of 96 newtons is applied vertically upwards as on block B as shown in the diagram below. I want the tension now. So because this block of A is opposed by the friction here, and I have the tension pulling this way, because I don't know the friction, I better use block B here to find my tension. So the tension here is going to be given by, from this equation here. Let's find out now. So we're going to substitute here. Now, guys, note that where the body is going, we make it positive. So here, we're going to have the applied force, which is 96. 96. Now the applied force altogether minus what? Minus tension, then minus weight equals to MA. But because of the constant velocity, it's going to be equal to 0. So in this case, I'm going to say 96 here. 96. Looking for this tension. What about the weight? It's going to be 8 times 9,8. Okay. Equals to 0. So I'm going to say 96 here minus 8 times 9,8 to get my tension. Okay. So calculator again. 96 minus 8 times 9,8. What do we get? It gives us 17,6. So we have 17,6 newtons as our tension. That's our answer there. Then here they said that we should find what next. Let's check it out. They said the string connecting A and B suddenly breaks while the force F is still being applied. Is the direction of the acceleration of block A now towards left or right? Explain your answer. Now, if the string breaks, it means that no more applied force here, but the initial momentum is taking it forward. However, the frictional force is pulling backwards, which is to the left. So the net force must be to the left because now the only remaining force is force of friction, which is opposing the motion and which is going to be to the left. So we say here it's going to be to the left. So it's going to be to the what? To the left. So it's going to be to the left. Okay, then they say here, explain your answer, because the remaining force, which is force of friction, is opposing the opposing motion direction, which is going to be to the left. Okay, then 3.5 here. How would the net force acting on block B be affected? Choose from increase, decrease, or remain the same. Now block B, meanwhile, it has its original 96 watt newtons pulling it upwards. So because we no longer have the tension here, okay, because the string was broken, we only have the weight. So the net force is going to increase because our F net, okay, our F net equals to the applied force, okay, minus now weight only. Now we no longer subtract the tension because tension is now 0. So it was going to increase, okay. So we say it increases. What do we say? We say it increases. It increases. Next question here. They said that a block M1 with mass 8 kg on inclined plane with a rough surface is attached by an inextensible string to an unknown hanging mass M2. Okay. A force of 20 newtons is applied to M1 down the plane from X to Y as shown in the figure below. Block M1 is moving down the plane at a constant velocity. The coefficient of kinetic friction acting on the block between points X and Y 0,2. A block M1, this is M1 here, this one here, a block of M1, a block M1 with a mass of 8 kg, as you can see it here. On an inclined plane with a rough surface is attached by an inextensible string to an unknown hanging mass M2, okay. Then they say a force of 20 newtons is applied on M1, this one here, down the plane from X to Y, okay, X to Y here. And then they say that, as shown in the figure below, block M1 is moving down to the plane at a constant velocity, not constant velocity again here. The coefficient of kinetic friction acting on the block between points X and Y is 0,2, okay. So what must we do? Let Newton's second law of motion in words. When a net force acts on the body will accelerate in the what? Direction of the force with acceleration directly proportional to the force and inversely proportional to the mass of the body. Then they say here, consider the motion of block M1 between X and Y here. Draw a free body diagram for block M1. Now this block M1 is on the incline. We want the free body diagram, okay? So now this is what we have here. In this particular case, what do we have to do? What do we have to do? Now our block M1 has got weight. It has the weight, guys. That's what you see here as my green arrow has got the weight. It has got weight altogether, so that's I'm putting it here now. It has got this weight. And then also our block M1 is on the surface. So the surface exerts a normal force. That's what? A normal force, as you see it here in blue. Okay. Now the normal force is perpendicular to the surface. So it will be like this, okay? So now when I bring it here, it must be like this, okay? Our normal force. Then there is tension in the string here. We have tension in the string here. We have tension in the string here. Now our tension is like this. It is in the string. It sits at this angle here. So we bring it here like this now. That's our tension in the string then. Then they said that we have a rough surface, and also have the applied force, right? Okay, so now the 20 newtons is what I have. You see it is acting part on the plane. This is my 20 newtons here. This is my 20 newtons here. I'm gonna put it in a different color here. Let me put it in black. Now this is my 20 newtons here. As you can see, it is applied downwards. So this is our 20 newtons here, which is part of the surface. Okay. Okay. So if I bring it here, like that's our 20 newton force, taking the block downwards actually, and then now we have the frictional force. We have the frictional force. The frictional force must be opposing the direction of motion. So this now is a frictional force here. It's opposing the motion here. Opposing the motion here. I'll give it this color here. So this is frictional force here, which you see in purple. Now frictional force arrow is always the shortest because the body is in motion here. Okay, so in this particular case, I have my free body diagram like this. Now normally we put a big dot here to show the free body. Okay, to show what the free body. Then now, guys, don't forget you must label your arrows. Now, if you don't want space, use the standard symbols. Ne? Just put here F normal. Okay, that's F normal. This are weight W. You can say FG. This now, if we know the applied force, put it there the way it is going to be 20 here. 20 newtons here. Here we have the tension. Let's use T. Then because the body is moving, we say this is F kinetic, meaning kinetic frictional force. Ne? Now, this diagram, I can also do it in another way, whereby I can split this Fg in components. And for that matter, would be like this now. So what you see here, when I come here now, what you see here, I can like this. I will actually have the applied force, okay? So you have the applied force as you see it here, okay? So I can put this side now. That's my applied force, all together. And then I still have the tension, right? Still have the tension here, So my tension is still acting upwards, altogether, upwards. And then it's in line, don't forget, tension upwards. Now I still have the normal force in the same direction, okay? Now the normal force is still normal. Now when we say normal in physics, we don't mean the normal in life sciences, okay? We mean 90 degrees, okay? Now this force which you see as, I still have the frictional force, by the way. Frictional force, I still have it. That is frictional force here. So the frictional force, I still have it here. Then note that in this case, my frictional force must also be what? In line. Okay. Okay, the frictional force. Let me just draw it again here. The frictional force, this one here, must get from here. Remember, it's opposing the motion. Okay. My frictional force must also be what? Parallel to the plane. Don't forget. That's what I'm trying to do here, to make it parallel to the plane. Okay. Okay, that's my frictional force here. Now, this Fg is going to be resolved into two components. One being perpendicular to the plane, other than being parallel. So I'm going to get a component like this. Let me use now a dotted line. Okay, dotted line in this case. Let me have it as a dotted line in this case. Okay. So I was saying that this force of gravity, which you see in green, okay, I'm going to get two components. One component is going to act like this. It's going to be perpendicular to the plane, okay? So this is my vertical component altogether, which we call Fg perpendicular. Then now the other component is going to be the one taking the block down the slope, okay? So this is my Fg perpendicular. We call it Fg perpendicular. Why? Because it is perpendicular to the surface altogether. Then I'm going to have my Fg parallel, okay, Fg parallel. Now this Fg parallel, it is taking the body down the slope, apart from the 20 newtons, but also Fg parallel takes what? The body down the slope. This is my Fg parallel here, and it It is also acting where? Downwards, ne? So it's called FG parallel. Why do we say so? Because it is parallel to the slope altogether. Alright, so we can show this. Don't forget again, this is my F normal here. This is F normal. This is the tension, okay, and this is the frictional force Fk. This was the 20 applied tension force. Yeah. So guys, free body, put a dot to show the body is free. Okay, then that is it. So you can show it like this, you can show it like this, or you can show it like this. They're all correct. Okay. Now next here, what must we do? They said that calculate the magnitude of the frictional force acting on M1. Now frictional force can be gotten in two ways. You can either use F net equals to MA, or you can use F friction equals to coefficient as normal force. Ne? So because here I don't have the tension force yet, I cannot use F net equals to MA because I don't know the tension. But because I know the coefficient, which is this 0,2, I can use F friction equals to coefficient times what? I can use now my frictional force Fk equals the coefficient times F normal. Okay. So now our F normal, as you can see from here, is exactly opposite to FG perpendicular. So I'm gonna say that it's gonna be coefficient, okay, multiplied by what? FG perpendicular. Now FG perpendicular, we use mg cos, okay? We use what? Mg cos. So I'm gonna use mg cos of theta. So the coefficient given to me was 0,2, 0,2. What about the mass? It is 8. What about the g? It's 9,8. What about the theta? It is this 30. Okay, I'm gonna say cos of 30. Cos of 30. So calculate as what we get here. Let's check it out here. So we have the coefficient 0,2 times 8, okay, times 9,8, then times cos of 30. Cos of 30. Which answer do we get here? As you can see, it is 13,58. 13,58. Now that's a frictional force, okay? It is 13,58. Okay. 13,58. All right. Now next, what must we do here? 4.1.4. They say calculate the tension in the string. Now that I know the frictional force, I can find the tension in the string. Ne? Okay. So the tension in the string here, this tension here, is opposing the motion here as well. So now because I know friction, I'm gonna find my T by using F net equals to MA, right? So I'm gonna say here that my F net equals to MA, F net equals to MA. Now our F net, the forces taking the body down, we have got the 20 and the FG parallel. So I'm gonna say FG parallel, okay? FG parallel plus what? Plus applied force, which is the 20 newtons, okay? Opposed by what? By frictional force, opposed by the tension, equals to MA. But because of what I said, the constant velocity is going to be equal to 0. Okay, so how do you find the FG? I use mg sine. I'm going to use mg sine and g sine theta, which is going to be sine 30. Then plus the 20, they give it to us. Now here we got 13,58, then equals to t, which you're looking for. So the mass is 8. What about gravity? 9,8. Then sine 30, sine 30, then plus 20, okay, minus 13,58, okay, to give us our tension T. So our calculator, I'm gonna say here that it is open bracket, I'm gonna say 8 times 9,8, 9,8 sine 30, okay, sine 30, which gives me this answer here. and then plus 20 to get this answer here, then minus 13,58, so I get my tension as what? 45,62. 45,62 is my tension in the string, okay? Newtons, okay? Then they said here that, what next now? They say that a man has a weight of 809,48 newtons on Earth. He then travels to planet X, whose diameter is what? This one here, and the mass is one here. State Newton's law of universal gravitation in words. I repeat, a man has a weight of 809,48 newtons on Earth. He then travels to planet X, whose diameter is this one here, and this is the mass here. State what? Newton's law of universal gravitation in words. How do you state that? Every body in the universe attracts every other body with a force that is what? Directly proportional to the product of their masses and inversely proportional to the what? The square of distance between their centers, okay? Now let's calculate the man's weight on planet X. Okay, so what do we know, guys? What do we know? We know that to get the weight on Earth, equals to the mass of the man times gravity. Okay. Now the weight on the Earth is 809. Okay, 809,48. Okay, 48. The mass we don't know. Okay, times 9,8. So our mass of this man is gonna be 809,48 divided by 9,8. Okay, what do we get here? Calculator. We have 809,48 divided by 9,8. 9,8. We get a mass of 82,50. 82,50. So this is 82,50 kilograms. Now I want the weight of the man on planet X. So the weight of the man on planet X equals to the mass of the man times gravity on planet X. Now the mass I noted this one here. So my task is to find this gravity here on planet X. So we know that that gravity of any planet here is given by G planet equals to the universal constant G, mass of X, divided by radius of planet X squared. Okay, so now our G is a constant. It's given by what? By 6,67 is negative 11 here. So we have 6,67 or negative what? Negative 11. Okay. So yes, times 10 power negative 11. Okay. And then times mass of the planet X, they gave us what here? They gave us 1,914 times 10 the power to the power. No, that's not the mass. Sorry, that's not the mass here. The mass here, it is 1,794. Yes, I can see it here. 1,794. 1,794 exponent what? 25. Okay. Then divided by the radius of the planet, that is 1,914 times 10 to the power 7. Now divided by 2, because they give us diameter, 10 squared here. So calculator, what do we get here? Let's check it out with the calculator here. What does it give us? Okay, so it gives us here it gives us what? Let's check it here. So we're going to have 6,6,67, okay, negative 11 multiplied by 1,7, 94, exponent 25, here, divided by we have 1,9, 1,914 exponent 7, right? Divided by what? By 2 to give us a radius here. It must be squared, okay? Squared and give us our. So we have got 13,06. Now this is our gravity here, 13,065. 13,065. That's gravity on planet X next. So we're looking for the weight of the man on planet X next. So weight equals to, the mass was 82,50 times now 13,065. So our final answer, just multiply by the what? By the mass, because the mass is constant. So times 82,5. So we get what? 1077,90. So 1077,90 newtons. Alright, thank you so much for watching. Get you next time. Subscribe to watch part 2. Bye bye.